Good afternoon. My name is TJ Kim from Midas, Singapore. Before getting started, if anyone can see the screen properly, please raise your hands using GoToWebinar function. If you have any question during the webinar, you can just write down the question in the question box. Then we will take care of the question. Purpose of this webinar is to communicate you better techniques of performing RC structural design in Midas nGen. This webinar will help you in learning quicker method of performing various jobs in Midas nGen. In the presentation, we will model RC structure and apply the loading, and even we will see design analysis and design process. So the first question is, what is Midas nGen? As some of you know already, and some of you don't, the most popular software of Midas in terms of structural analysis and design software is Midas Gen. So we got a lot of questions that what is Midas nGen, or what is the difference between Gen and nGen? The main different concept between Gen and nGen is the model system. Midas Gen is node and element modeling base, and Midas nGen is object modeling base. In other words, in Midas Gen, we need to generate node and element for our model, but in Midas nGen, we need to generate the members such as beam, column, wall, slab directly. Because of this difference, modeling sequence is different, and loading, design, or other processes is also different. So today we will see the difference of Midas nGen modeling of RC structure using the program. Then let's look into the software from now on. So this is the software Midas nGen interface. So as you see, the interface system is quite similar to Midas Gen. So we have main menu here, and we also have the work pane, and we have model view, and there's also analysis message here. So the main interface is quite similar. So now I start from the scratch using this Midas nGen to model RC structure. So before I start the modeling, I actually want to show you the application area. So actually this file is application material catalog for Midas nGen. So this kind of office structures, so there is a 2 tower in one model, and diaphragm, we can also make it diaphragms. And office structure, also different kind of office structure. We have the window load, auto generation function, and seismic load. So this loading system also we will see today. And also school facilities. So this kind of school structure, we can also do it, and we can also apply the earth pressure loading. And there is a curved shell loop here. So even this kind of curved loop we can also simulate in Midas nGen. And there is also complex facilities. So in those kind of facilities, we have different slab level, and then we have beam in between. So in this kind of shape, if you want to generate in other software, it's quite tedious job. But in Midas nGen, we have special feature to generate this kind of modeling very easily. And this is more structure. So we have curved wall here, and then we have flat slab, meshed flat slab. We can even handle this kind of structures, or housing facilities. So we have a plan of the house plan, and then we have a similar plan in the several stories. So this one we can also handle in Midas nGen. And some other general structures we can also handle in Midas nGen, and even steel structures we can also model and design in Midas nGen. So today I will show you the RC structure. So let's look into the software. So first I will create a new file. So also in Midas nGen, there are several ways we can start the modeling. So usually for RC structure, some other software we need to create the grid system. So if I go to structures, and there is we can also generate our grid system. So we can also define in X and Y space, or even we can also define Z level. So this is 3D grid system, so you can actually use this kind of grid system in your model. And the advantage of this grid system is, for example, so let's say we have the 3D grid system here. Then we can also work in 3D mode, or you can also make it in plane mode, which means I can also work on this some specific plane. So if I want to work on this specific plane, so you can go for this specific plane and you can work on here only. So other part will not affect it to your workspace. We can modify only this space modeling. So this grid system is quite useful to generate our model. But this time I will use our special feature, tracing feature. Okay, so not only for using this grid system, but also we can use architect drawing in our modeling. So if I go to create tracing file, then we can actually open our architect drawing in our another software, Midas Drawing. So in Midas Drawing software, we can actually modify this architect CAD file to Midas nGen tracing file. So this is the software Midas Drawing. This one is we usually use for edit the tracing file, but you can even use this program as a drawing program. Like AutoCAD drawing program, we can actually use this Midas Drawing. So if I open this CAD tracing file, here we can see the center line or column line, wall or dimension, grid bubble, and undefined. So you can choose your specific layer, and then you can define your center line or column line. So we can make it this tracing file. So if you want to add additional layer to each specific purpose, you can even categorize those layers here. So editing this tracing file is not take long time, so we can easily modify here, and then you can save this CAD tracing file, named it, and then we can make it path, and then we can save it or export to Midas nGen. After that, in Midas nGen, we can go to this tracing file import. So here we can open this 3 CAD tracing file, floor first floor, second and third floor, and then we can import to Midas nGen model. So data has been imported, so we can go to story, and here we can create our new story data. So I will make it 4 stories with 4-meter high, and we can specify our story each architect drawing here by each stories like this. And then if I click OK, so we can import the arc drawing into our model. So as you see here, we imported 3 different story architect drawing. So if you want to work on one specific story, we can go to story mode here, and then we can choose each stories. So we will work on the first story first. So as you see here, not only for column or beam layer, but also we can see some other undefined layer together in this model view. So how we can use this architect drawing in modeling? So in members, for example, if I want to generate columns, so the usual way, the common way is we can click this point to generate the columns, or we can also select some grid connectivity, intersect grid, and then we can generate the columns. So that is usual way in other software. And in this Midas nGen, we have architect drawing here. So here we can choose the option. Even we can also generate by one point. This is we can click the column and we can create our column manually. But we have this feature by select auto generation function. If I use this one, I can just drag my mouse, and then here the program will search the column layers, as you see here. And then we can just click apply or click enter. We can generate our RC columns. So as you saw already, I didn't define any section size or I didn't define any position, but program automatically detect the layer, and then it define the sections as well as the positions. So we can easily model these our columns. And how about the wall? Wall is quite similar, so we can generate the wall. So there is also several methods. I will choose wall. So we can also generate wall by 2 point, or by select the line segment, or we can also use by select closed line. So if I use this function, we can draw the mouse and then it will detect the wall. So I can click enter or click OK. Then we can generate our walls. So if you want to add additional wall or curved wall, we can even use this feature, draw feature, and then we can generate our wall, additional wall here. Okay. So let's see the other members. So how about the beam? So we can move to the second floor. So if I choose the second story, then it will affect that we can actually work on the second story. So now here we can choose beam. We can choose beam here. And then there's also we can draw, or we can choose this line segment. So I will choose the beam section, let's say SB. And using this feature, we can actually select this line segment here. And then we can click enter or click OK to generate our beams. So this one actually detects the center line of our drawings, so we can directly generate using this, or we can also use this by draw option if you want to generate your own beam. So I can just draw to select to generate my beams. So the additional beams we can directly generate using this feature. Okay, so how about this slab? So we have this slab here, so we can go to slab, and then we can choose the membrane or plate slab. So we have two types of slabs, so plate and membrane. So if I choose this membrane slab, then in the design process we can actually design in one-way U-line method, one-way, two-way design slab. We can do the design like that. So here we have also by select or by draw. So as you expected, if I use by select, then I can actually select the panels. So if there is a beam frame, then we can select like this the panels, and then click enter to generate our slab. Also here we have the by draw option. So as you expected, we can just click the position to generate our slab panel. Click enter to generate our additional slab. So generating slab is quite easy using this kind of modeling feature. And I just wanted to show you the opening of this slab. So in some other software or even in Midas Gen, as you know, in RC structure, the opening, generating opening is quite tedious job. But here in Midas nGen, we can just go to opening. So we can select the one slab and then go to opening. And here it will ask by select or by draw. So if I using this by draw option, we can just generate our shape of the drawing opening. Let's say this kind of shape, and then click enter. We can easily make it this opening. So later, if you want to modify these openings, we can also change these dimensions. So we can use dimension option to see the dimension of this opening dimension. So I can also modify our openings. And if you want to display your dimension, we can use this measure option. So we can even display our distance of each members or each openings or dimension we can actually display in our model. So now I will show you just the basic modeling functions in nGen. So like, okay, here if I want to generate, let's go to the first story. Measure, I will hide all. Okay, so here let's say I want to generate our additional column, then we can just create the using this by one point, and then we can just generate our columns 1 point. So we can generate wherever we want. And the copy option, let's say I want to copy this column to here, then we can select and just to press the keyboard Ctrl C, then we can copy our columns. Or if you want to move these columns, we can use the key shortcut key Ctrl we can use the shortcut key Ctrl M, and then we can also move our columns. And if I want to extend this column length, then we can use this dimension, and then we can also extend our column length. So this kind of basic modeling is quite very is simple and is easy to use. For example, the beam, I show you that we can draw this beam on our any place, right? So if I use this one, if you want to generate your slanting beam, then you can just click. I will make it 3D view, and we can just click to point to generate our beams. So we don't need to use the story mode here. We can directly go to 3D mode, and you can just click to point to generate slanting beam or bracing. So the modeling feature in Midas nGen is quite simple and very easy to use. So this is very convenient way to for engineer to model our structure, RC structures. So now let's talk about the loading. So modeling feature, we can actually use this kind of modeling. So after that, we can also copy, or we can use the copy the stories function. We can complete our model. So for loading part, I will use the complete model here. So this is actually same as what I modeled previously here in the first stage. So I just finished the first story, and then I copied to upper stories. So this is the finished model, only the model. So how about the loading system in Midas nGen? So we can, let's see here what we have. In the loading part, we have self-weight here, so we can actually apply the self-weight. So we can also even define our load set. Let's say dead load and live load, like this. And also we can generate, I will apply the self-weight first. And the basic loading system, for example, point load or beam load, we can also apply some basic loading. I just show you one example. So beam load, I want to apply live load beam load, and then I can just choose some beams, and then input the values, click apply. We can apply our loading. So pressure load or temperature load, we can use various loading system. And then here we have slab load. So if I show you the slab load, so I can define our slab loading. For example, this is office 1 area, and then I will apply the 2 number of loading type. So dead load, I will apply -5, and live load, I will apply -2. Click on add, and then go to the slab load. We can apply the loading, office 1 loading, to this panel. For panel, we can apply the loading. So in this way, we can apply the slab loading as well. And floor load also, let's say we don't have the slab member, we just apply as the loading type. Then we can use the floor load. And the arbitrary loading, for example, here in this slab, plate slab, if we have the plate slab, so let's say I want to apply the loading like on some random position here on the slab, then we can use this point or line and pressure load. So for example, I will generate the point or lines face body. So let's say go to the plane mode of this slab, and let's say here I can generate any position point, or I can generate any position of line, and then I can generate any position of face. So I can draw the face somewhere here. So I have point, line, or face. Then in the load tab, arbitrary load, we can use the point load. So we can using this body, and then we can apply the loading. Or we can use this arbitrary line load. So we can select this body, line body, and then we can apply the loading. So if we want to apply the 2D pressure load on this slab, so we can also use arbitrary pressure load. So we can select this face, and then we can apply the loading like this. So we can apply the point load or line load, pressure load, any position of our slab panel. We can apply this arbitrary load on our slab panel. Okay. And some other lateral load. For example, in RC structure, we need to apply wind load, or seismic for static seismic load, or response spectrum loading, and earth pressure loading, and imperfection loading. Those all kinds of loading system is available in Midas nGen. So how about let's see the wind load. So here in the wind load, we can create our wind load functions. So Eurocode, and then we can apply our height of structure, and then we can input the basic parameters. And then here in the Eurocode, we have various effects we need to consider to calculate our wind load. So orography effects or neighboring high-rise structure effect, those kind of effects, we can just check on consider effects, and then after we input these basic parameters, we can consider those effects automatically by the program. And the structural factor here is 1. Actually, as you see in the Eurocode, we can even use structural factor 1 for our structure, but we need to satisfy some criteria. Otherwise, we need to calculate this structural factor. So if I go to this dialog box, so we can actually calculate our structure factor by clicking this calculate button. Then program will give you the structure factor here after many process, and then we can use this parameter here, factor here, in structure factor. And pressure coefficient as well. So here we can choose the structure type, and then consider option. We can choose internal or roof as well, and then auto calculate or pressure coefficient. We can just input the breadth and orthogonal breadth, distance, and then we can just click OK. Then program will calculate the coefficient as well. If you have the roof part, we can even consider the roof coefficient as well. So after we generate this wind load, and then we can define our wind load functions, and after that we can assign this wind load to our structure. So this function we can apply to enclosed area, or we can even apply to open structure area. For example, if there is no wall here in this kind of steel structure, we need to actually apply the wind load on the columns here only. So in this kind of system, we can even apply the wind load or equipment, and we can apply to story structure. So our structure we apply in story structure. So if I choose here, actually wind load will be generated every directions. So if you see here, generate orthogonal direction and then generate negative directions. And we can even choose the direction as well. And then we can choose the wind load function here, which we define. And then it will show the wind load profile. So 30 force, shear, and overturning moment. And then we can click apply to apply our wind load. So it's very simple process that we can apply the automated wind load on our structure. So similarly for static seismic load, so here we can actually define our seismic load function similar to wind load. So Eurocode, we can choose the ground type, and then we can choose the spectrum type, and then importance factor, and then we can even choose the period calculation formula. So if I click calculate button, then program will calculate, and then we can generate the function similar as wind load, right? And then we can use this function to apply our seismic load. So also response spectrum seismic load. So if you want to apply your dynamic seismic load, response spectrum seismic load, so we can actually specify our spectrum data, and then we can apply the dynamic response spectrum earthquake loading. And if you want, we can even apply the earth pressure loading or imperfection loading. So this one is recently we added for Eurocode. So we can actually use those kind of loading system here. Now let's see the analysis and design part. So in this way we can apply the loading. So I will open the prepared model. So this one actually same way I applied all the loadings, and then I actually run the analysis. Actually, in order to reduce the time, I prepared the model. So actually, when you perform the analysis in those kind of model, for example, we want to check some kind of modeling information. For example, here in the check model, we can actually check the duplicated member here. If there is some duplicated member in our model, we can check using this one. Or if there is some small gaps in between some element members, we can even check those things. Or in the face, some incorrectly divided or some duplicated 2D element, we can even check those kind of model by the program. And then in analysis tab, for example, if I want to control our mesh size or system, we can go to analysis setting, and then in the mesh, we can check the mesh size of 1D and 2D members. So those mesh size we can even control in here, analysis setting box. And load combinations. So in steel or RC, we can automatically generate our load combination as per the code. So using this template box, we can choose the Eurocode, and then we can add our load combination by the program automatically. So let's see this model. So in the load combination, I already defined the using the Eurocode data. So here we have the nonlinear load combination data. So actually in some other software, if you want to apply the load combination, perform the nonlinear analysis, since we apply the static load case, we need to actually generate nonlinear load combination separately. But in Midas nGen, there is an option. We can just check this option to perform the nonlinear analysis using those existing load combination. Very simple. So we can just click check on, then we can use those load combination in nonlinear analysis. And now let's see the analysis result. So in the result tab, we can check the various analysis result. So for example, we can also check the deformations. We can check the deformations, or we can check the reaction forces or moment. So we can also check the values together. And other forces or beam diagram, beam forces or stresses, we can check every result in here. And when you run the analysis, we can also run the design result together. So if I go to design, so here we can even setting the design case, or we can even define our design group or define rebar, those things. We can also perform everything. So in the design data, we can actually check our design information here, or we can also check the design result. So for example, strength check. So we can check the strength check here, or we can also see the ratios, and we can even check the serviceability check. So when I click this status, then program will also give you the design result of need to check or is okay, and is critical or is not good. So those things we can also check in the control type. And we can also see the flexural 1D flexural member beam, and then we can even check the values, see the values, or shear ratio, or deflections, and then we can even check the negative and positive directions. And then in the RC members, we can also see the report. So in the design report, we can go to design report here. So we can see as many as we want. For example, beam, we can just select the several beams if you want to see the report. So I just select one of beam and column and slab. So let's see the design report for beam. One beam and one column, and we have wall, and we have slab. Okay, so we can generate the summary report or detail report. So summary report, so if I click summary report, it will generate this kind of summary of design result. So there's a beam design result here, and then columns or war, summary report, and then slab. So it will combine those design report in one file and then generate automatically outside of Microsoft Word format. And let's see how about the detail report. So go to design report again. I just select beam and then column separately. Detail, choose the detail report and then create the report. So if you know about the Midas Gen, actually we know that there is also summary and detail report. So in the detail report, there is each step-by-step calculation process even in Midas Gen. But Midas Gen is kind of text format file, but here in Midas nGen, we can actually see in Microsoft Word format file. So there is a calculation information and then process. Even we can see the formula and then Eurocode section here. So we can check this kind of detail report. So for shear, so there is the information and then equation, each step-by-step calculation process. So using this report, we can also submit this report, or we can even compare with our handy calculation result. And the advantage of the Midas nGen, we can even generate the slab, membrane slab report. So if I generate a detailed report of this membrane slab, so we can also see the report of one-way, two-way slab design. So this is quite simple design for all the engineers. So you can even do by yourself, but program actually generate the report automatically. And also this is Microsoft Word format file, so we don't need to adapt other new software. We can directly modify in this Microsoft Word. So those are report generation. And also if you want to see in the edit reinforcement, or if you want to see the result of the design, you can also see in the table format. So like beam, if I click all, then we can see in this kind of table format. So there's story, design set, and design group, and member section, and then main bar was applied like this, and then stroke. So also there is a checking result of all the members. And then also if you want to see the selection, so we can just select several members, and then we can see those results. Separately in this table format. Beam and column also. And in this way we can actually perform our design of RC structure here. So actually I didn't explain all the process of design, but actually here in design process we can actually set the design setting, or we can also go generate the design group by auto generate of design group. and then member parameters. For example, here if I go to member parameters, so for RC member parameter, so we can see target ratio. We can define our target ratio, or we can also define the various parameters. Stress parameter for serviceability check, or exposure grade for crack check, and then crack parameters, deflection parameters. So those things we can also define in this design parameter, or table of RC member, for example slab. So we can also set our design information of slab here, so target ratio. And even if I go to here in the deep table of rebar for slab, we can open a table format as well here. And the define rebar type, so we can also define the beam type of rebar here. Or for example slab, we can even choose the type A or B type, C type, D type, those kind of type we can also even choose, and then we can modify correctly in according to this kind of type here. So distance, diameter of the rebar, and then spacing. So we can change all the design information for our model. So now let's see about the drawings, generate the drawings of our structure. So here we can move to the report and drawing tab, and then we can go to setting, and we can set our drawings. So in the drawing set 1, we can see column layout or plan drawings. So if you want to add more components, so here we can modify it, and then we can click generate drawing button. So if I click that option, then program actually try to export from Midas nGen model file drawings to this Midas drawing program drawing file. So it's automatically connect those drawings. So now it's finished to export the drawings. So we can go to drawing creation here. So here we can go to floor plan creation. So we can check on the drawings which you want to generate. And then we can set the position, and program will generate the drawings of column layout. And some other drawing, for example, here in the floor plan, so we can check on the floor plan. And then we can generate the drawings here, floor plan. So in this way we can generate our structural drawings using Midas nGen and Midas drawings. So basically with using this Midas nGen, the RC structure modeling to design is quite easily we can handle. And then there are various features that we can reduce the time to work of these RC structures. So actually today's webinar is actually this is today's webinar contents. So if you have any questions, then you can actually write down your question now, and then we will reply to your question. Thank you.